Aloha, Richard Halverson here. This is ITS128, and it is the third class recording. And as you know, I'm doing 4 this week. And so I'd like to continue on. The first 2 recordings covered chapter 1 and a lot of good hints in there. And so I'm gonna share. So let me share my screen right now. All right, let's see. So we are syllabus. So I'm oh, I guess I haven't posted up. I'll put class number 2. Class number 2 is yesterday. I'll put that here, and then when I'm done with this class right now, this is class number 3. I'll put that one here also. So you'll see those links there. So we're doing. I finished chapter 1 here, class number 2. Today I'm going to start on chapter 2, and I'd like to finish chapter 2 today and tomorrow. And again, you don't have to come to these videos, or you don't have to come live, synchronous, but you want to make sure that you watch them. Well, you don't have to watch them if you're just breezing through and you're getting all the points and everything, and you don't have to stress about anything. There's not going to be any important there's not really going to be any important announcements in these videos that would not also be in an email. So anyway, so I wanted to remind you where to find the videos. They'll be there, and they will also be in resources in Spring 2021 videos. Okay, so the second video is going to go here. And the third one will go here also. And by the way, while I'm down here, I'll just point out that there's the videos from last semester are pretty good also. I'm first couple of chapters aren't that great, but after a while I sort of got into a groove, and I cover a lot of the exercises and labs and so on in the previous semester. So if you want to get ahead, you can take a look at those. Okay, and then the second thing I wanted to remind you is, make sure you go to this when is good, click here to your when is good and sign in, and check off the days, and the ones that you've checked off in the afternoon should still be there, but I've changed the morning ones to on the half hour also. So as I'm studying where people can be placed, or when I should schedule my classes next week, I end up getting a lot of I end up not being able to cover everybody because everybody who signed up in the morning is not showing up. So anyway, I might make some adjustments or assumptions from your current settings for when the morning times were on the hour. But if you could, I'd like you to keep that up to date, because the dates and times will change. I may add some more evenings. I may add something on Saturday, just depending on how things go and my schedule. Next week, for example, I'm busy all day Monday. So anyway, let's go to chapter. We're in chapter. We're going to start chapter 2 now, and in this chapter we're covering variables and expressions. And so let's just get started, and I'd like to just go through this to make sure that you understand what you're supposed to get out of these little fun little exercises. So here, let's see what the people on a bus. For each step, track through the number of people typing in the number of people. Okay, so this is a concept of a variable. And the variable has a name. The variable name is called num_people. And it's got a little container associated with it that can store, it looks like a number. You know, it's a variable that can store numbers. Okay, so it's a variable that looks like it can store integers. Okay, and maybe not numbers with decimal points. But anyway, so notice up here on the right, there's this thing is empty, and that means you haven't gotten any points yet. So if you click on start here and you say you were driving the bus starts with 5 people, and then 3 people get in. And then how many people, what's num people now? Well, I guess num people must be like 8 or something. Just, I don't know if I'm doing this right. Ah, correct. Okay, what's next? 3 people, okay, we're back to starting with 5 again. 3 people get on and 2 people get off. So we're at 5, 3 people get on, that brings it up to 8, and then 2 people get off, it goes back down to 6. So I guess the answer is 6. Okay. What's next? All right, 3 people get on, 2 people get off. So I guess we are 6, and then 4 people get off. So we're at 6 and 4 people get off, and it goes down to 2. Okay, I'm going to try answering a wrong answer just to see what it's like. So this should be 2, but I'm going to go 3. See what happens, just to see. Boom. Oh, nice. All right, so now what do I do? Click next. Oh, it's the same question. Okay, 2. All right, there we go. So that's what happens when you answer a wrong answer. See, I still don't have any points. I'm just trying to get to the point where I get some points there. And now 5 people get on, and so that brings it up to 7. It looks like 7. And then I guess 4 people get on, so that brings it up to 11. Okay, there's the checkbox there, and that means that I got the points for this participation activity. You see, I didn't really have to do anything except for just click through, and I get as many chances as I get and all that. And I kind of get the idea of this variable where you have a variable, and it's a container that stores a value in between these operations, or in between these things that are happening. So it's kind of like the memory. That's the memory of the computer. So anyway, so that's a variable. That's exactly how a variable works, except for these would be statements. These would be assignment statements. Okay, particularly ones that add or subtract from the current value. So so this here goes through the concept of these variables and assignments, and you got to think about programming where something like this is an actual operation that happens. There is the state of the computer before this is executed and the state afterwards. It's not like algebra where these are actually truths. You know, these are truths, and you're trying to you know, arrive at the truth, which in this case here would be x equals 2 and y equals 3. Here we are trying to compute something. So anyway, so I like to put it on double speed. And so here we got these 3 variables, and here we assign x equal to 5, and here we assign y equal to whatever x was, and then z to whatever x plus 2 is. And then we go to, then we're doing some stuff where we reassign x equal to 3. So if the 5 is gone, you know, we really even shouldn't have this sort of faded 5 here, because there's not a faded anything in there. And then we, what did we just do? I don't know what we just did, but anyway, so this goes on. We're explaining, it's explaining the difference between these statements and these statements. Okay, yeah, so Anyway, so that's that. Oh, did I get all the points yet? No, I didn't. I guess I got to click all the way through to get all the points. So this is why people, there we go. Yeah, when I download the scores, I notice that, the participation is something. It's worth something. And I notice that people, it's worth 35% of your grade. So you want to click through and get all the check boxes. And I notice when I'm downloading scores that a lot of people don't do them. Because why? Because they probably know the vast majority of this stuff already, and so this is just BS. I mean, if I were taking the course at the time, I mean, I learned how to program in high school. So if I were starting, after high school in a class like this, learning this stuff, I would be skipping all of this participation stuff also. But anyway, sorry about that. And maybe I should think about that when I'm weighing these parts in the future. But there's a lot of people that this does not come naturally for them. They're this is no longer high school. This is post high school. This is college, and you all have other lives, and you're all doing stuff, and so it takes a while. It may take a while to get your mind into the mode of what programming is all about, and they kind of need this part, and so anyway, bear with us on this. And so this talks about what the equal sign is, and the equal sign is really assigning. It's compute what's on the right of the equal sign, compute whatever that is, and take that single value and pop that into the container that's identified on the left. So indicate which assignment statements are valid. Yeah, this is valid. This is valid. This takes whatever y was, adds 2 to it, assigns it to x. That's valid. Ooh, this is not valid because this 3, and then we try to assign, this is an assignment statement. This means assign. This doesn't mean it's equal. It means make what's ever on the right be what's on the left. And so here, this is not. So anyway, so that's not valid, and this is not valid either. So you can only have a single variable on the left. By the way, in other languages, it's not equal sign. In Pascal, for example, Pascal was the ICS111 language, and probably the language for ITS128 language back in the 90s. I taught when I taught ICS 111 back in the 90s, and instead of having x equals 5, that's how it is in Python. In Pascal, it was x colon equals 5. So this was the assignment operator. And the reason they did that is because they didn't want to confuse people into thinking somehow it was defining an equality like in algebra. But we all kind of got over it, and we just use the equal sign now. It's a lot easier. So anyway, you want to go through all these, and then you get all the check boxes. So you should really go through these and figure these out yourself. You can kind of you just start clicking around, and it tells you. What I'd like to focus on in these videos is more the challenge activities. Here, I want you to know what's going on, and actually these progression challenge activities also are something you should be able to figure out. But what might not be as easy to figure out are some of the challenge activities where you have to actually write some code, and you can put something in here, and you're clicking around, and you're just not, and why? It's because it's something basic having to do with the fact that you're learning programming for the very first time. A lot of you are, and you just don't know what, you're getting syntax errors, and it's because you don't know what the syntax of a program is. It's like if you're learning a new language, a new speaking language, and you learn the meanings of a bunch of words, but then you try to talk the language, and you're not going to make any sense because you're saying all the words in the wrong order. So anyway, so here's one here, 2.1.2. Write a statement that assigns total coins with the sum of the nickel count and the dime count. Okay, so we have two variables, a nickel count and a dime count. And we want to assign a variable called total coins equal to the sum of those two numbers. And so, for example, 100 nickels and 200 dimes equals 300 coins. Okay, so here's the starting of a program. And let's see what this program does now. Okay, first of all, the program defines the variable total coins. It's in fact, it initializes it to 0. You should always initialize your variables to something. And then it asks the user to enter in a value for nickel count. That's when this input, that means ask the user, or it's expecting an input from the user. Okay, so there's that, and then this int around it means it's, we're going to interpret it as an integer number and not a string or a word or anything. So those two get added in there. Or so now we're just going to write a statement here that adds these two together and stores the value in total coins. Well, this is just simple. And if you don't get it, it's because they're not asking the question in a clear way, is what I'm trying to say. So we're going to clean up that clarity, or we're going to make it clear here. It's just something like a nickel count, that value plus the value of dime count, and that should be it. And you can run it, and test. You get all the tests, you get all the point. You get a nice big checkbox check there. I can't remember how much these challenge activities are worth, but they're worth 2-3 points or something. So that's good. So that's that one. What's this next one? Multiply the current value of a variable. Okay, so here you've got a variable, and it asks the user what it is. So, that's going to assume to be, when this thing is, when Zybooks is testing your solution, it's going to put values in there for that. You only have to put in the thing that makes cell count multiplied by 10. So if the input is 10, the output should be 100. So it's cell count times 10. So to multiply cell count by 10, okay, so here we are reading in cell count, and then we're actually manipulating cell count itself, and then we're going to output cell count again, but cell count's going to have this new value. If this value is 10, then this one's going to output as 100. So what that is it's you take the old cell count, and you make this equal to the old cell count times 10. And for times, you do an asterisk like that. So, what we're learning here is that in an assignment statement, you compute whatever it is on the right. That's going to be an expression, and you're going to bunch of math type stuff. You're going to do a calculation, and you're going to end up with one number, and then that number gets stored into the variable that's identified on the left there. So this takes the old cell count, multiplies it by 10, and stores that back in cell count. So now cell count's got a new value, and it's the old value times 10. Anyway, so now what I'm going to do is I'm going to write the wrong answer just because I want to see what the wrong answer looks like when it tells me. I'm going to make this a plus sign because I'm stupid. And I'm going to say run, and it goes, boom. Ooh, my output is this, and it's expecting, oh, I got the 0 right, but I should have a 1 in front. Yeah, it should be 100. Yeah, okay, that's nice. And I didn't get any points. All right, so let's fix this. Multiply. All right, there we go. Oh, I got all the points. Good, check. Okay, it's 11:21. Let's do some more. Multiplying the, let's see, what's So identifiers, is this 2.2? Well, I guess we don't have any challenges in here. Okay, identifiers, the name of these variables that we've been seeing, like, under something num underscore nickels or whatever, those are just the names. And this talks about what are valid names. And valid names, it always has to start with a letter. And and then after that, it always has to start with a letter or an underscore. It has to start with that. And then after that, it can have any of these, all three of these sets of types of characters. Lowercase a, and it differentiates between lowercase and uppercase. So it gives you more possibilities, but it gives you more ways to make a mistake. And then an underscore is like a letter. So you can start a variable with an underscore, in other words. And then you can throw, after the first character or letter or underscore, you can throw in digits if you want to, but it can't start with a digit. An identifier cannot, so a variable name cannot start with a digit. It's case sensitive, which means lowercase is different than uppercase. There's certain variables that you can't name, so you can't use, like this. You can't have a variable named true with capital T. You can't have a variable named and, just like that, because those are what are called reserved words or keywords. They have special meanings in Python, and all languages are like this, pretty much. Actually, that's not true. In PHP, all variables have to start with a $sign, so it can be anything. Anyway, so what are valid names? This is valid. This is certainly valid. This is valid. Yes, it is. Two of them, sure. No. Can't have a space. No, can't have a space. So that's invalid. No. Can't start with a number. That's invalid. Yeah, and don't see anything wrong with that. Can't have, what is this? I don't even know what that is. Can't have that. Yeah, I think you can. Is this a reserved word or anything? Yeah, okay. Yes, valid. Okay. And see, I got all the check marks there. Got a big check mark up there. All right, but they have recommended ways of you naming these things, whatever. Okay, here's a list of the reserved words. There could be more reserved words in this, but here we go. They all mean something. So this is a list of words that mean something in Python, if you want to know that. All right, and there's a link to it. All right, 2.3, are there any challenges in here? No, I don't think so. Okay, this is objects. Okay, so Python, so back in the old days, we didn't have a concept of an object in our programming languages. This is new. This is after the 90s. After the 90s, and so objects are like containers that have variables in them, different kinds of variables, but they're all kind of associated in some way. And there's also code, little programs in there too that can serve kind of interface to those variables. And so, you ask the object for something, and that may be just a variable that's stored inside of it, or it may have to be the result of some computation, and then that's what it gives you. That's and that sort of implementation detail is hidden from you. That's the idea behind an object. Okay, so all right, so you should understand, and it's a little weird the way they explain objects in Python, and I'm still not quite completely comfortable with it. Sometimes they call things objects when really they're actually just variables, and it's like when you have this statement x equals 7, it's like they say you're creating an object. An object is a new object with a value of 4. Okay, here, this. Okay, so this statement creates a new value with a new object with a value of 4, and then it's that 4 is stored somewhere, and then when it's printed out, it's the object itself is stored out. To me, that's kind of a complicated way of thinking about this. But anyway, so you know, should understand this, but it's not really going to be any tests on this. It helps you conceptualize really what's going on here inside of the Python interpreter. Yeah, that makes sense. See, that makes total sense. Print X, that makes total sense. This 2 plus 2 created an object in there named 4. You know, that is actually what happens, but this is the first language where, when they're explaining it at this level, this is the second week of your first programming class, they talk about it that way. All right, well, anyway, so you can go through this. So it's 11:30. Let me let's go to 2.4. There's a challenge in 2.4. Floating point. Let's see how far we. What's the next one? Arithmetic expressions. Okay. Anyway, so let's so here we're talking about, you know, these variables, these containers. We distinguish between the types of things that we can put in there. We distinguish between an integer which does not have a floating point, which does not have a decimal point, and those numbers that do have a decimal point. Okay, so and there's, you know, lots of reasons for that. One important reason is when you're dealing with numbers that don't have decimal points, then you know, in other words, integers, whole numbers, you can use whole numbers very easily to step through a list, or if you have a whole list together and they're all in order, you know, you want to iterate through them, iterable, iterable. Uh, so integers are iterable, whereas floating point numbers are not, because you can always, if you have any two numbers, you can always, you know, you can always write down what what a number is in between those two. And so anyway, so that's part of the motivation for distinguishing between these. Also, division is different between floating point numbers and integer numbers. So anyway, and then there's this thing called scientific notation, which you should understand. This is 1 times 10 to the minus 4 power, which is a single digit, it's 0.0 point, is it 1, 2, 3, 4? That's what this is. Yes. So anyway, and that's because in programming, we can represent some pretty big numbers and pretty small numbers, and depending on what you're doing. So there are a lot of these interesting examples here in this textbook, and I haven't really looked at this, so I'm not going to really say much about it. But I think in the future I'm going to take a advanced look at some of these things, because really what this is doing is it's an application, you know, a real life application where you're computing all these different energy values, values related to energy. And there's a bunch of different ways of expressing numbers, and we see, you know, that's one way of doing it. You know, what's, you know, like this is a speed of light. This is whatever joules, joules in a AA battery. That's how much energy is in a AA battery. Anyway, and then it computes all these conversions and so on. So anyway, overflow means that you have your object, or you have your container that's storing your integer, and you try to store in a number that won't fit. Okay, so you know you've defined a particular type of variable container already, saying it's an integer, or you might say it's a string that's 100 characters long, and that's my variable there. And then you try to store something in there that's 105 characters, and it overflows, so it doesn't store it. You don't know what's in there most of the time. So anyway, you know, you have to worry about that sometimes. Let's go down to this challenge activity. Oh, here are we explaining about formats? Yeah, okay. Time to start talking about formats, isn't it? This is unique to Python, which is one of the things when you're coming from another language. You spend a lot of time trying to remember this stuff. So here, with this format statement, so this is what we're writing out. This is like the object. This is the object that we're writing out. Now, with objects are associated these methods that go along with an object, and one of them is this format method. So they make this real complicated when they're explaining it, but we are writing out this number. We're writing out this number, and we're writing it out using this format. And what this format is the colon means there's going to be anything on the left. There can be anything on the left of the decimal point, and we're going to put 2 digits to the right of the decimal point. Okay, max. Okay, so for example, that's what if it's 2. Now here's an example if it's 4. See here we're taking pi. This is another way of expressing pi because it comes from this class, this math class. Boy, they're sure throwing a lot at you in these early chapters. Anyway, so this is pi, and you know what pi is. It's 3.14159, that. But we only want to print it out using like 4 decimal digits to the right of the decimal point. So this is how we do it. We say we're going to write out this pi. We're going to write it out, and we don't want it to see. Oh, by the way, this program. This is the output to this program. So the first thing we're doing is we're just writing out pi, and it looks like this. And of course, there's actually more, but there's a default. And then we're going to say, but when we do it only to 4 digits, and then we'd have this fancy print here because we don't want to put a return in there. And then it prints out pi, but pi is formatted. Pi is formatted. How is it formatted? According to this format here. And this format here says whatever to the left of the decimal point, you know, whatever it takes, as many digits as it takes. It may not take any digits in which case you don't have anything over there. But then we only want as many as 4. No, we want exactly 4 digits to the right of the decimal point. And so that's why it ends up looking like this. So anyway, while I'm here, I might as well grab the points. Well, that's nice. Very good. Check. Okay, challenge activity. Oh, we just have to write. You want to compute the gallons of paint. 1 gallon per 350 square feet. And we're inputting square feet, looks like, wall area. We're inputting the square feet. And we are going to do this math, and then we want to print out how many gallons of paint it takes. Well, so it takes 250, 350 gallons equals. Let's see, how can I erase this? How do I erase this like this? Yeah. So 350 gallons, 350 square feet gives me 1 gallon. 250 square feet is X gallons. That's the equation. And so to solve this equation, we cross multiply. So we get 350X equals 1 times 250 is 250. So we have that equation, and we want to solve for X. So we only want X on one side and everything else on the other side. So we divide this by 350, and we divide this by 350, and this cancels, and we have X equals 250 over 350. X equals 250 divided by 350. So the number of gallons equals 250. So here's the equation is going to look like, gallons paint equals the 250 is the input number, 350 is this constant. It's this constant here. So 250, this is the number that was input. So this is equals wall area, because that was the number that was input. And then I'm going to divide that by 350. That's a constant. Oh, look, gallons equals the square feet divided by 350. Okay, so I just showed you a little bit of algebra there. Algebra is not something to be afraid of. All right, so anyway, let's run this and see what it looks like. Oh, look, I got the right answer. All right, very good. So it's 11:39. I'm gonna I've gone through section 2.4. 2.4. I'm gonna jump down to a lab. Okay, these are a little bit more difficult. All right, so lab. This is divide by X. Write a program using user num integers. This integer. Okay, so we have 3 variables. We have this variable and we have this variable, and they are both integers and with their input. And then we print out this variable, which is divided by this variable 3 times. Okay, right. All right. Oh, and we output each time. Oh, clever. Okay. And I guess we want to do this integer divide. And why did they tell us this? Have we talked about integer division yet? Well, I don't know, but this is the integer divide symbol. And maybe I can show you that. Are we supposed to use integer divide? Oh, anyway. Okay, so we have to input. I guess we have to input. All right. So the first one is we're going to input the user number. Yeah. Okay. So user number equals input, and that's where so it'll be sitting there waiting for a number, but it's an integer, so we can do this. Or we can do that, or we can do. All right, we're just gonna integerize it right here, and then we're also going to input x. X equals int input. Okay, so that is going to sit there and wait until the user types in a value for x, and then it's going to start doing some calculating and printing. And first, it's going to print out this, which is x user num divided by x. So I'm going to say user num. Oops. I'm going to say user num equals user num divided by x, and then I'm going to print. User num. Okay, and I'm going to make a mistake and not put this tail end thing. Let's do it. And equals a space, not a return. Okay, so I'm in development mode. Let's see what this does, by the way. So run the program, and what happens? Bung! I forgot to put the input. Okay, so the first thing I'm going to do is I might as well just do the same numbers that were up there. So I'm going to do 2000 and 2. And now when I run this program, it goes 1000. Okay, now look. So this is not an integer. This is a floating point number, and I wonder why it did that. Because this is an integer and it's an integer. Integer divided by, oh, I know, it's because we did floating point divide. Okay, this is integer divide. Bump. Run program, and it looks like that. Now, I'll show you the difference between integer divide and integer. Let's do 5. Let's do 5 divided by 2. Regular divide. Oops. 5 divided by 2 regular divide, and we get that. If we do integer divide, the 0.5 gets hacked off. Okay, so that's integer divide. So you integerize it. So anyway, I guess we want integer divide. I suppose we could do this, int and let's do 2000. Okay, okay, so that's that part, and then we got to do it. We have to do it 2 more times. So 2 more times, yeah. How does that work? Whoa. All right, so so the way you submit now is you click submit mode, and then you click submit for grading. Now, what happens if we, I'm going to see what happens when, tell you what, I'm going to do this because this is what, no, I'm going to not do this. I'm going to take the ints out and see if what happens when it's floating point. I want to see what the error message looks like. So I'm going to click on submit. Okay, first of all, click on development and see what it looks like. It looks like that, which is not the right answer. So what happens when I click on here? Oh, I see it. It just doesn't like us. Here's what happens when you. It should be just 2561, and here it's got these decimal points. So anyway, you know how to do that one. You should be able to finish this problem now. I sort of stopped in the middle here, didn't get any points, and you should be able to fix that. I'm gonna do the next one. We've got a little bit of time here. Let's see, driving costs. Okay, here we got this fancy print format thing, and what this does is we're gonna write this number, and we're gonna write this number, and we're gonna write this number, and this is the format we're gonna use. And the first one here is gonna be this one, and the second one will be this one, and the third one will be this one. So, and it's these curly braces here that designate that correspond to these numbers in the same order. You can put anything you want inside here. You can put words, you can, it's really whatever this string is, and then in place of what these values are, you indicate those in order with these strings of characters. So anyway, driving is expensive. Write a program with the car's miles per gallon and dollars per gallon as input, and output the gas cost for 20 miles, 75 miles, and 500 miles. Okay, so this must be 20, 75, and 500. So here we're inputting the miles per gallon, 20 miles per gallon. And this is the, this is how much gas costs. Okay, so up on the mainland, I guess gas is just cheap. And then, so if you have a car that gets 20 miles per gallon and you are paying this much for gas, then the cost for driving 20 miles is this, $3.16. The cost for driving 75 miles is $11.95. And if you're going to drive 500 miles, it's going to cost you 79 bucks. Okay, so, and we're supposed to write a program where the input is these two and the output is these three numbers. Okay, so miles per gallon and dollars per gallon. Okay, so input miles per gallon, equals, and we're inputting floating numbers now, so float input, and then dollars per gallon equals float input, and so those are the two inputs, and then we're going to compute your value 1, I'll just call them that. We're going to compute your value 1 equals something, and we're going to do your value 2 equals something, and your value 3 equals something. And then we're going to print out this. Copy, paste. All right, and now all we got to do is do that. Figure out what it is for this. And what it is it's going to be, all right, let's pull up our whiteboard again. I'm going to put this over here. I want to finish this at 11:55, okay? So we have miles per gallon. Miles per gallon And then we have dollars per gallon. And we want to end up with dollars. We want to end up with, oh no, we want to end up with dollars per mile. This 316 here is $3.16 per 20 miles. Let's first figure out, okay, so we want something where we multiply by miles. We want miles times something equals dollars. That's what we want. Well, what's miles times something equal dollars? Miles, gallons, we have miles, and then we, let's see, if I want gallons, what happens if I divide? Hold on here. Dollars per gallon. So take dollars per gallon and divide by take dollars per gallon and divide by miles per gallon. So dollars per gallon, let me erase this. How do I get rid of this thing again? Delete. How do I delete that? Dollars per gallon divided by, no, times it, divided by miles per gallon is the same as, I take this and I flip it over and I get gallons per mile, right? So that's, so by taking this and flipping it around, it's the same as that. And I can get rid of this now. Shoot. So now we have dollars per gallon times gallons per mile, which is the reciprocal of this. Oh, shoots. And so this now is the gallons cancel, and we have dollars per mile. And this is what we want. We want a dollars per mile number, because then we can multiply it by the number of miles, and we get dollars. So if you multiply this by 20 or something, we get for 20 miles, it costs 20 times whatever the dollar. 20 times this thing gives us the dollars that 20 miles cost. So what does that mean? Let's go down here, and I'm going to first compute some value. I'm going to compute dollars per mile. Dollars per mile equals dollars per gallon. Dollars per gallon, it was this equation right here, whatever this was, dollars per gallon divided by miles per gallon divided by miles per gallon. Okay, so this is dollars per mile. And so now dollars per mile times miles equals dollars. So dollars per mile times 20 is going to be the first one, and times dollars per mile times, what is it, 75 will be the second one, and dollars per mile times 500 will be the third one. Dollars times 500 will be the third one. All right, so I'm just going to see what this looks like. Develop mode. I'm going to put in these numbers: 20 and 3 1599, 20 3 1599. Run program. 316 1185. Ah, looks right. Okay, anyway, you can test that with other things. So it's 11:57. I gotta go someplace right now, and so I hope this helps. I've finished the first 2 labs in chapter 2 and the first 4 sections in chapter 2, the challenge exercises. And if there's no questions, I'm gonna upload this video, and I will see you one more time. This is ITS128. I'll see you tomorrow at 1:30. The following weeks, I'm not going to meet with you 4 times a week, but I wanted to get these chapter 1 and 2 under our belts. So starting next week, we can have a little bit more relaxed schedule. All right. So thank you, Cassidy, for coming, and I will see you next time. Thanks for watching.